Hello, ladies and gentlemen. I'm very happy to welcome you to this session on solar mini-grid best practices for regulatory frameworks. Once again, I would like to thank for their support to the International Solar Alliance and the Clean Energy Solution Center. They are making possible these training sessions. Some background for me. Before I joined Factory in 2010, I have been Director for Policies and Finance at the International Renewable Energy Agency, IRENA. There, I was responsible for the design of energy access work program for the agency. Previously, as a Spanish civil servant, I have been involved in many national and European regulations for the promotion of renewable energies and energy efficiency policies. Today's lecture, in today's lecture, we are continuing with the module on off-grid, solar off-grid, and we are continuing with the lectures devoted to solar mini-grids. So we will go into the details today on how to set the right regulatory framework to promote solar mini-grids. In this module, we will, as always, start with a brief description and definition of what a solar mini-grids are, and afterwards jump into the main body of the presentation. Don't forget, at the end of the presentation, you will be given the chance to test your knowledge with a little quiz. The learning objective, which this module aims to provide, can be divided into three parts. First off, we will learn about the regulatory and policy framework of mini-grids more generally. This is followed by a discussion on energy sector governance and more specifically on energy policy. Finally, we will talk about economic policy and regulations with respect to mini-grids. Be reminded, this is part one of the two-part module on mini-grids regulation and policies. A quick backup of the kind of technology we are talking about. A mini-grid, also sometimes referred to as a microgrid or isolated grid, can be defined as a set of electricity generators and possibly energy storage systems interconnected to a distribution network that supplies electricity to a localized group of customers. Mini-grids offer an alternative that entirely avoids many of the challenges that new and expensive grid infrastructure investment require. Mini-grid systems are becoming increasingly competitive compared to the cost of traditional grid extension programs and are a key component in achieving universal access to electricity for all. The reason for this are the rapidly decreasing cost of the technology, increasing reliability, and a solid deployment track record, all of which have strengthened the case for the accelerated adoption of mini-grid solar solutions across the world. The main body of this module is divided into three parts. We will begin with an introduction and then slowly work through the different perspectives of regulatory frameworks for solar mini-grids. The mini-grid policy and regulatory framework comprises the binding rules, strategies, institutions, and associated processes that govern the mini-grid sector. It is developed and adopted by public bodies, including parliament and government agencies, and it determines whether and how mini-grids development take place, as well as whether and through which modules mini-grids are developed, implemented, and operated. The principle of mini-grid policy and regulation should, in the best case, be stable and non-live, clear and comprehensive, accessible, cost-effective and efficient, light-handed and simplified, as well as transparent and predictable. Main mini-grid policy questions include the discussion of whether or not to integrate mini-grids as an option for rural electrification, which approach to implement, how the approach is to be financed, whether and how mini-grids are subsidized, as well as which electricity tariffs are to be applied. During this and the following module, we will try to find potential answers to all these questions. Regulation is always based on principles, either intended or unintended ones. This slide gives a short overview of recommended policy to follow for the design and implementation of mini-grids regulation. A stable policy and regulatory environment is the basis for attracting investment into mini-grids. Mini-grid investors require assurance that both macro-scale and specific regulatory support mechanisms will remain stable and predictable for the life of the project. There is nothing that makes investors, both existing and prospective, more nervous than the feeling that the regulatory environment may shift beneath them once they have already committed to their project. An incomplete or unclear mini-grid policy and regulatory framework will hinder rather than foster mini-grid rollouts. There should be full clarity on permitted tariffs, license and permit requirements, import duties, VAT, company taxes, and other possible incentives and subsidies, as well as other policy and regulatory issues discussed in the next sessions. The process by which regulatory decisions on these issues are reached should be clear and standardized for all transactions. Policy and regulatory frameworks should seek to ensure that the points of contact for permitting, technical and financial support are easily accessible and available. The stakeholders should be able to contact the agencies that are key to implement their project. Regulations, procedures, and potentially resulting delays create transaction costs for the project developer, which are particularly critical for a smaller developer. After all, mini-grids run on the razor's edge of commercial viability. It is thus of paramount importance to design a mini-grid policy and regulatory framework that is cost-effective and efficient. A regulatory framework that minimizes bureaucracy delays for granting licenses and permits, responding to inquiries, or providing other support. In general, for solar mini-grid, the less regulation is often the better than more regulation, specifically with the small mini-grids. For instance, a capacity below 0.5 megawatts. Very small mini-grids can be exempted for all regulation, as it is the case in Tanzania and Cameroon for mini-grids below 100 kilowatts. Regulatory decisions must be transparent, fair, independent of power supplies, and prevent government interference in day-to-day operations. Furthermore, regulatory decisions on similar issues should be consistent with previous decisions to give greater credibility to the regulatory process. Incentives for mini-grids should allow a level playing field between rural electrification technologies and between alternative energy sources. All potential cost-effective mini-grid technologies should be considered in a mini-grid policy and regulatory framework. Before mini-grid policy and regulation can be designed, the basic political decision whether to include mini-grids in the rural electrification strategy has to be made. Following this, further strategic decisions have to be taken before going into the detailed planning of regulation and its implementation. This decision relates to the general approach to be adopted, centralized versus decentralized, upfront financing, government versus private, and tariff, cross-subsidized versus cost-covering tariff, each of which is discussed afterwards. These decisions determine which mini-grid operator models can be applied in a country. Sometimes it may also be beneficial to support more than one operator model. In other words, these decisions are crucial starting points since they are streamlined subsequently throughout the policy and regulatory framework. Most governments, particularly in Africa, have developed national electrification strategies following either the centralized or decentralized approach. In a centralized approach, national government entities such as public utility, rural electrification agencies, or ministry undertake electrification alone or together. A national grid station is usually the primary means to electrification, with mini-grids playing a minor role. With the decentralized approach, private and community players take over the electrification of areas far from the national grid, but are often still supported by public institutions in the planning, implementation, and operation of the mini-grids. Mini-grids can be an integral part of both approaches. In the centralized approach, either a public utility is given the mandate to install and operate mini-grids, or the state can own and or operate generation and distribution of mini-grid assets. In the decentralized approach, private companies or communities are allowed to own and operate generation, distribution, or both types of assets. Following both models in parallel is possible, but requires more effort and capacity, including very specific policy instruments and regulation to clearly define the roles and responsibility for all actors. Governments have to decide which approach to follow or whether to pursue both tracks at the same time. Mini-grid deployment can be accelerated if regulatory processes are streamlined and actors are given the necessary tools and guidance for developing and implementing mini-grids. Levels of governance, involvement, and types of operation model are interdependent and determine the pace and eventual success of implementation of mini-grids. Support instruments like subsidies, tax breaks, etc. can accelerate the rollout. Upfront financing of mini-grids can be provided by the public sector, the private sector, communities, or foreign donors, both public and private. Public financing is the primary approach for the centralized track using utilities under national list to improve electricity access. The decentralized track usually involves other financial actors. This is mostly done out of necessity. Public budgets are limited and the investment cost of providing electricity access is high. It is widely acknowledged that for providing universal electricity access, private investment is needed in the most developing countries. Private investment is more easily attracted by private operators. Community contributors are also important as they improve a project's financial sustainability. Public actors must reconcile institutional, political, and financial reliabilities with rural development aspiration and the aim of achieving the highest possible rate of electricity access. Governments are assigning roles and responsibility to specific public bodies to support mini-grids, and are sometimes creating a new public agency to assume previously assigned responsibilities. In general, mini-grid institutional stakeholders should have specific responsibilities that are clearly allocated to a single actor to allow high cost effectiveness and accessibility. It is the role of the Ministry of Energy to design rural electrification targets, strategy, and mission, to design and administer national energy policy and planning, and to define rural electrification strategy, including the selection of the operation model. Further, the ministry is responsible to administer public resources allocation and to initiate the mini-grid regulatory and institutional framework. The Finance Ministry takes the role of the Treasury. It provides a rural electrification budget, avails and coordinates grants and concessional loans, provides input on national electricity tariffs and subsidies, and determines stability of investment policy and decides fiscal incentives. The energy regulator facilitates the implementation of rural electrification targets, vision and mission, formulates and implements technical, economic, and legal regulations. It is also mediates in disputes and provides an advisory function to other entities. The National Environment Agency ensures that the mini-grid meets national environmental standard and is responsible for issuing licenses and the monitoring of compliance with environmental regulations. The Rural Electrification Agency is responsible for driving implementation of selected national operator models and, in some cases, performs specific regulatory tasks. Also, it manages mini-grid project cycles, channel loans and grants for mini-grid projects, for instance, through a Rural Electrification Fund. The Rural Electrification Agency is also required to monitor and evaluate mini-grid projects and develop electrification plans. Last but not least, regional authorities take a array of responsibilities, including the provision of support for the identification of targeted areas. They authorize land use and award building permits and resource utilization permits. They promote mini-grid programs and facilitate contact with the electricity users. Finally, they support the training and forming of capacities. We will now identify and discuss policy and regulatory instruments for mini-grids. The policy and regulatory instruments are embedded in a broader process of designing and implementing a mini-grid policy and regulatory framework. This process can follow various paths, led by the decision and action from policymakers and regulators. An overview of the main linkage between the different policy and regulatory levels is given in this graph. Many instruments are linked, and their effectiveness and efficiency depend on other instruments. In this graph, the two paths shaded in red represent the priority policy and regulatory instruments, which include all the foundation elements that have to be in place to allow the development and operation of mini-grids. The gray shadow box in the bottom represents supportive policy and regulations that help scale rollouts farther and faster. Without this, key actors may be reluctant to participate and invest, or may wait for other players to pave the way before they start investing. We will now go through these components in alphabetical order, but please bear in mind that this was part of the two-part module with only will cover box A and B. A1. National energy policy defines objectives, identifies priorities, and outlines the broad guidelines for sector development. This might encompass the energy sector as a whole or focus on a specific subsectors such as electricity and electrification. A key element and a pillar of public support of a national rural electrification policy in general and mini-grids in particular is the political aim for universal national electricity access, setting targets and backing them up with political by providing the necessary framework and resources leads to focused action by the involved stakeholders. Another essential aspect is the explicit decision to integrate solar mini-grids into the rural electrification approach. Subsequently, the policy should identify appropriate operator models in the respective country contexts, as each of the four basic operator models, utility, private, community, and hybrid, for solar mini-grids require specific policy support. The energy or electrification policy thus lies the ground for the entire enabling environment, which is further operationalized at the subsequent levels. If national electricity access targets are not to be achieved, stakeholders need a plan to get there. For rural areas, this plan should at least indicate grid and off-grid areas on the basis of a state-of-the-art tools, including GIS-based spatial planning software. Thus, it is beneficial for solar mini-grid developer if the Ministry of Energy, assisted by its National Electrification Agency, develop a rural electrification master plan. This electrification strategy and master plans will ideally be based on data about the existing or potential income generation capacity of the beneficiaries of the electrification, the distance from the main grid, the population density, equity between geographic areas, and the local energy resource potential and cost. Energy, electricity, or renewable energy laws or acts establish the legal and institutional framework for public planning and the implementation and enforcement of regulation for rural electrification in general and mini-grids in particular, usually through an act of parliament. They lay down the responsibilities of important actors and provide the basis for any specific regulation or promotion instruments. All the instruments presented in the next slide and the second part of this module needs this legal foundation, as well as public institutions to implement the energy and electricity laws and design and enforce energy regulations. Very important part of all the solar mini-grid enabling environment is the tariff setting. A tariff is any charge, fee, price, or rate that has to be paid for electricity purchases. The regulation of tariff is central to the viability of any solar mini-grid business. The design of tariffs highly depends on regulation and on available financial support, such as subsidies, debt service, as well as on expectation for return on equity for utilities and private operators. Factors such as population density, electricity demand also influence the economics of mini-grids and need to be considered while setting the tariffs. Generally, tariffs and connection fees, together with subsidies, must strike a balance between commercial viability of the solar mini-grid projects and consumers' availability and willingness to pay. Tariffs should aim to attract private parties to invest in mini-grids. Also, they should make solar mini-grids financially viable and sustainable. Tariffs can also proceed to support economic development and improve living standards in the villages. They may enable better understanding of mini-grids operation. In the end, however, the tariff's main challenge is to balance sustainability and affordability. Generally, policymakers must define solar mini-grid tariff structure that strike a balance between commercial viability and consumers' availability and willingness to pay, as we said before. However, since electricity generation costs for mini-grids are higher than grid tariff, a politically equally issue arises regarding whether and how to subsidize electricity in a higher rate for off-grid people. We will now look to a couple of options available. A uniform national electricity tariff with equal tariff for mini-grids and national grid consumers throughout the country, which usually imply crop subsidization for rural electricity customers. Cost-effective tariffs for mini-grids on a national level, which needs a national consensus to accept different electricity tariffs for mini-grid customers. An incremental introduction of cost-reflective tariffs starting on local level in order to determine whether it is politically sustainable. However, this is a high-risk option for project developers. With cost-reflective tariffs, only the people consuming electricity provide the revenues for recovery, mini-grid investment and operation and maintenance cost. The equity issue comes into play here. Why should the rural pool pay a higher price for electricity and the fundamental service it provides, when the urban, middle, and upper class enjoy electricity that is subsidized by the country as a whole? On the other hand, rural communities are generally willing to pay a fair price for consistent electricity power. After all, consumers need electricity much more than they need low tariffs. Yet, purely cost-reflective tariffs are relatively high for mini-grids, even though they may be the most cost-effective solution for scaling up electricity access in many regions. With a uniform national tariff, the main question is, who is subsidizing mini-grid tariffs? Is it the whole population through extra subsidies financed by government budgets, or existing customers through higher electricity tariffs? Indeed, electrification in most countries was and is financially supported by governments, and subsidizing mini-grids can be the best option to provide quality electricity wherever mini-grids are more appropriate than the available alternatives. Finding a combination of both, the golden mean, is probably the most pragmatic solution for scaling up electrification. We also have to face a second challenge, is how we are going to set our tariffs. The most common approach is to set the retail tariff based on energy. So the customer will pay for the energy they consume. They will pay for each kilowatt hour. Of course, in this case, the metering is required. It has this approach several advantages. You don't need to set limiters in the households. And also, there is a great incentive for energy efficiency. Nevertheless, you will need readers, and of course, you bear the risk of customers' unpayability. This is what afterwards you can set a postpaid or a prepaid system. So to reduce the risk of customer unpayability, you could set a prepaid system where customer buys energy before consumption. A second option is to set the tariff based on capacity. This option is also known as a flat rate subscription tariff, where customer pays a maximum power amount. In this case, an overcurrent device is required or a load limited. The main advantage is that no metering is required, no bill calculation, no meter reading required. The main disadvantage is the high charge per kilowatt hour. So we don't know how much is going to be the tariff for each energy unit. It don't have any efficiency incentive, and this discourages any productive use since the load is limited. In this case, it has to be implemented within a prepaid system. Less usual, but also possible, is to set the rated tariff based on services. Here, the energy is not sold anymore per units of energy consumed, but it is based on the service they provide. So how, for instance, how many kilograms can be treated in a mill, or how much water can be pumped. The advantage is the required precise and adequate calculation of prices, relates energy to other activities, so also relates energy to incomes, which make more affordable. But of course, once again, we are hiding the real price for kilowatt hour, and there is no incentive for energy efficiency. The system is billing post or pay. Finally, the last possibility of setting a tariff is per device. So people will pay in advance in relation with how many devices they are powering. This is used to reduce the initial cost and to start electrification from a very basic and low level. There is no need for metering, but on the other hand, it is needed to do an inspections very regularly to be sure that the people is not increasing the number of devices. So you don't need equipment also for tariff. Reduces the grid consumption, and also you can know in advance more or less how much is going to be your consumption, but nevertheless still so little incentive for efficiency because you pay for the device and you don't care if your device is not efficient, and it discourages also productive uses, and of course it hides once again what is the price or should be the real price of each kilowatt hour. In this case, the billing, it has to be prepaid. Before we talk about the components C and D from the energy sector governance box on the top left, we will now have a look at the fiscal policy and the regulation part, the top right box. Fiscal policy and regulation can support mini-grid implementation through low taxes and import duties, accelerated depreciation, or subsidies. Tax on income, company profit, sales, properties, value added, or other taxes should not exceed the level of conventional grid supply and can be reduced further to stimulate the solar mini-grid market. The same holds true for import duty, taxes and fees, which can be reduced or exonerated for solar mini-grid equipment or components in order to support the mini-grid market. In general, the lower these taxes and import costs, the lower solar mini-grids electricity tariffs can be. Accelerated depreciation allows a lower tax burden in the early years of the project. This depreciation should also be allowed for assets that are provided through grants, as these have to be replaced at the end of their lifetime. These fiscal rules should be clear and reliable to improve investor trust. This table provides some further information and explanation on the respective instruments. Real-life example can be found in different parts of the world. An example of the beneficial income tax treatment can be found in Sri Lanka, where a 5-year income tax holiday applies to power generators using renewable energies. In Madagascar, according to their tax code, investment in renewable energy can benefit from a reduction in corporate income taxes equivalent to 50% of the investment undertaken. Also in Madagascar, equipment from the production of renewable energy is exempted from the value-added tax. In Brazil, companies producing electrical energy from wind, solar, and hydropower enjoy reduced import taxes. Once again, in Madagascar, also, investment in equipment can be depreciated at an accelerated rate of 30% of the net value. And finally, in Nepal, an arrangement has been made to refund VAT to small hydro projects developed and operated by community based on consumers committees that do not elect to take the zero rate on import tax. It should also be noted that while these instruments apply to generally all of the early introduced operator models, they represent only a subordinate role for the utility approach. For the hybrid, private and community operator model, they are, however, important tools. Ladies and gentlemen, we will stop here and come to the end of this module. In this module, we have looked at the energy policy and fiscal policy and regulation. In the following session, we will continue with this customer environmental regulation, licenses, and contract regulation, as well as with the support instruments. As concluding remarks, the mini-grid policy and regulatory framework comprise the binding rules, strategies, institutions, and associated processes that govern the mini-grid sector. It is developed and adopted by public bodies, including parliament and government agencies, and it determines whether and how solar mini-grid development takes place, as well as whether and through which model solar mini-grids are developed, implemented, and operate. The principles of solar mini-grid policy and regulation should, in the best case, be stable and long-lived, clear and comprehensive, accessible, cost-effective and efficient, light-hearted and simplified, as well as transparent and predictable. We have so far only learned about the first scope of policy instruments, but already it is clear that their respective success is a function of context and diligent implementation. With this, we are coming to an end. I would like to thank you for all our attention, and I am hoping to be able to welcome you again in the second part of this module. As always, I would like to invite you to test your understanding with the following small quiz. Thank you very much.